we are using in these two steps. So in the estimate step, it means that in the first step we are taking we are considering the estimation of our z values. So here the z values are estimated by the probability that instance xi was generated by the jth Gaussian. So how we are calculating that? So we simply use our probability density function to find these things. Okay, so we know that here these formulas are the probability density functions. Okay, so to use this one we require the mu value as well as the variance value. Okay, so with the help of these available mu and variances, we simply find the estimated value for our z. Okay, so this is the estimation step. And coming to the second step, in the second step that is the maximization step. So in this we simply calculate the new maximum likelihood hypothesis, that is the h bar. That one be calculated with the help of this particular formula. Mu z is equal to sigma I equal to 1 to m estimated value of zi into xi. Here these estimated values are used to multiply with our instances, because here we are considering these as the weights. These are the weights. Okay, because each zi value zi are having either 0 or 1. So if our instance is generated by that particular distribution, then we need to consider that as 1, otherwise we need to consider that as 0. So whether we need to consider this xi for identifying our mu value is based on this z value only. If z is 0, we need not to consider it. It means that 0 into something is a 0, so automatically this term becomes 0. So summation of these things means here zi is acts as the weight value. Okay, so here with the help of this one we simply find out the new mean values. So after finding the new mean values, we need to take the new hypothesis. This new hypothesis must be replaced with our old hypothesis h. Okay, so here this is the formula which whenever we need to go with the k Gaussians. Okay, suppose we are going with a single Gaussian or single single normal function. In that case, our mu value is only sigma I equal to 1 to m xi by m. This is the normal mean function. Okay, so these are the two main steps we need to go. Okay, and coming to the main essence of this particular EM algorithm, so whatever the things we discussed it, based on that we simply considered main steps in that. So here the current hypothesis is used to estimate the unobserved variables, and here the expected values of these variables are used to calculate an improved hypothesis. So it means that, so whatever the current hypothesis we are having, that one be is used to estimate the unobserved variables. Here what are the unobserved variables? In our case z values are the unobserved variables. So here we are estimated those values with the help of the current hypothesis. So after getting those estimated values, we simply calculate the improved hypothesis. Okay, it means that whatever the current hypothesis we have, that is that one be improved with the help of estimated unobserved variables. Okay, and it is also shown that in the each iteration our loop of estimation maximization algorithm, which is increasing the likelihood value. Okay, so that is the probability of our given data conditioned on the h. So that one is maximizing unless it is a local minimum. So it means that up to it get as the local minimum. So this one be these steps must be repeated. Okay, so at last we get a hypothesis, updated hypothesis. That one is having the mean values mu1 and mu2. Okay, so this is the main essence of our EM algorithm. And coming to the pros and cons of our EM algorithm, so pros of our EM algorithm are, so this one be in every iteration of our EM algorithm results in a guaranteed increase in likelihood. It means that in every iteration the likelihood value must be increased, and whatever the steps we are having in this, we have the expectation step and maximization step. Here these two steps are very easy to implement. Okay, and coming to the cons, so here our EM algorithm takes both forward and backward probabilities into the account. Okay, so generally most of the numerical optimization techniques follows the forward probabilities only. forward probabilities only, but our EM algorithm is follows the forward and backward probabilities. This is a contrast one with our numerical optimization techniques. Okay, this is the first con, and second one is our EM algorithm convergence is very slow. Convergence of the converging, it means that in every iteration we are checking that whether it is converged or not. So here the converging is very slow, and only it uses the local optima. It is not going with the global optima. Okay, so these are the pros and cons of our EM algorithm. Okay, so, this is the information regarding our estimation means of k Gaussians with the help of our EM algorithm. And coming to the self-assessment tests, here we have two true or false questions. So the first one is EM algorithm can only be used for parameter estimation of mixture modes. So no, it's not correct, because EM algorithm is also used to find the latent variables, and it's also basis for our clustering techniques, and it's also used to train our Bayesian networks. Okay, so this particular statement is false. And the second one is every iteration in EM algorithm results in a guaranteed increase in likelihood. Okay, yes, in every iteration our likelihood must be increased. So this is true. Okay, so these are the two self-assessment questions under this particular concept. Okay, thank you.